Hi everyone. Welcome to this series on skeletal system and bone tissue. In this series of 3 presentations, what I really hope to do is to give you a better understanding of bone structure, the skeletal system as a whole, and the concepts of bone remodeling and bone growth, as well as bone healing. In the first presentation, what we're going to do is talk about bone in general, look at bone tissue, and then talk about the functions of bone. Bone does far more than just create a skeletal structure or a rigid structure for the body. It also performs a lot of important physiological functions. In the second presentation, we'll talk a little bit more in depth about bone cells because we need to understand these cells and how they contribute to bone remodeling and growth over time. We'll also talk about different aspects of bone structure, including bone shapes and the way we classify bones based upon their shape. We'll also look at the anatomy of a typical long bone and talk about the different types of bone that are found in a particular bone, as well as bone marrow. In the final presentation, we'll talk about bone growth, how bones get bigger and longer over time. We'll also talk about bone healing and how bone adapts to the stress that we place upon it. So let's get started and take a little bit closer look at bone structure and its function. In this presentation, I hope to go over a number of different things related to the skeletal system and how it's involved in movement. First off, I want to go over the function of bone. There are a lot of different functions that the bones of our body provide, but I want to focus obviously on the ones that are related to movement. I want to briefly go over the histology of osseous tissue. Again, how is bone structured? Because I think that we need to understand how it's structured to have a better understanding of how it has its strength and how it has its elasticity, because these are going to be very important factors when it comes to, again, preventing bone injury, but also being strong enough to act as a good framework for our body as a whole. And then finally, I do want to talk a little bit about the change of bone over time. Bone is not an inert tissue. A lot of people think it's inert, meaning it doesn't change or modify itself much, whereas in reality, it's a tissue that modifies itself very readily, fairly rapidly, has a very good blood supply. But because the matrix of bone is so dense, it does take some time to take old matrix away and lay down new matrix. And we'll talk about that in this presentation. Hopefully by the end, you feel like this guy, very relaxed and chill, and are ready to move on to the next presentation, which is on the joints of the body. So what are the functions of bone? Again, this is something I'm sure you covered in previous classes, but primarily for this class, we're going to talk about movement, but obviously bones do other functions as well. They act as a support system for the body. They obviously give us a framework for our body. They give us the shape of the head, the face, and the body as a whole. They also are going to protect the different parts of the body, most importantly, some of the vital organs. Our cranium protects our skull, our rib cage and sternum protects our lungs and heart and other organs, and so on. They also are going to provide a framework to support the weight of the body. So again, obviously, all of the different structures of our body are hung from or suspended from the skeletal system. So they provide this support for the body's weight. And as I said, they protect the eyes, ears, and brain in the area of the head. There are some other functions, and the ones that are most important for us are the fact that bone acts as a lever. Okay, our muscles, obviously skeletal muscles, attach to bones at or near joints, and when these muscles contract, they're going to move the bones at these joints, allowing for movements such as walking and running and all of the different things that we do. A lever is a concept that we're going to go over in a future presentation. But again, a lever is a simple tool created by early man. And a lever can be thought of in a number of ways. But again, a seesaw is a type of lever where we have basically an axis of rotation. We have a rigid bar of some type in the human body, that would be a bone. Again, this axis of rotation can be called a pivot point or a fulcrum. That would be our joints. an object that is moved against resistance, which again could be the weight of our arm or leg, or the weight that we're holding in our hand, and a force that supplies this energy, which in the case of human movement would be muscles. So again, our bones are going to act very importantly as levers to allow for movement of our body as a whole. And again, if you think about how many different ways they do this, we're lifting a weight, walking, running, all of the multitude of physical activities that we engage in involve our muscles pulling on these bones that are acting as levers and moving at the joints of our body. In addition to functioning as levers for human movement, bone plays another important role in that it houses bone marrow. Bone marrow is going to be important because it basically is going to allow for the storage of fats and the production of some blood cells. Bone marrow comes in two different types, and they're named based loosely upon their color. Red marrow occupies the spongy portion of bones, specifically the skull, the ribs, the sternum, the clavicles, and the vertebrae, and in the pelvis. The red marrow in these bones is going to be very important for, again, human performance, because it is where red blood cells, white blood cells, and platelets are going to be formed and then obviously placed into our bloodstream. So our body is constantly turning over the red blood cells, white blood cells, and platelets that are in the bloodstream, replacing them with new ones and removing older ones. This is probably most important, or probably the most important cell for our concern is going to be red blood cells, because red blood cells obviously carry hemoglobin, which is what allows us to move oxygen around the body, specifically from the lungs to working muscle. So the red bone marrow, if you suddenly engage in an increased amount of aerobic activity, your red bone marrow will start churning out red blood cells at a quicker rate than they were before you started this exercise routine. Additionally, each red blood cell will have a higher amount of hemoglobin, therefore a higher oxygen carrying capacity. And again, when you combine the higher amount of hemoglobin per red blood cell and a greater number of red blood cells, you can get a fairly dramatic increase in oxygen carrying capacity in the bloodstream, which would convey very significant benefits to an endurance athlete. Yellow bone marrow, it fills a lot of the other bones, the long bones of the body, and is going to be basically a storage site for fat. Fat obviously often gets a bad rap. We do need some fat in our body, and fat is an important energy source, especially when we're at rest or at lower intensities of exercise. We burn fat as a preferred fuel. It's more efficient than burning carbohydrate. Just can't do it as quickly. So bone marrow serves those two important roles. One, as a place where we can basically form new red blood cells and other blood cells, and then also a storage site for fat. We can see a picture here. This is the head of the femur. The head of the femur has been removed and cut open so that we can see inside of it. We're going to talk about bone structure, but basically the outer portion of the bone is going to be encased in or going to be compact bone. So the outer portion of a lot of bones is going to be this very compact, dense bone, and then the inner portion tends to be this spongy type of bone, which has these kind of nooks and crannies, these little areas that are filled with marrow. The head of the femur actually contains both some red marrow and some yellow marrow, and we can see the differences here. Red marrow has that red color because of the blood cells that are found in it. That are forming, and then yellow marrow, obviously, because it's a fat storage site, is going to be yellowish, which is the color of again, lipids. Bone also performs another important role, and this again involves storage. Instead of fats or lipids this time, it's inorganic salts. So things like calcium, sodium, magnesium, potassium, and other things are stored in bone. So bone plays a very important role in storing some of these important substances. Calcium is the one we think of the most, and calcium is stored in the bone, but also contributes to a great extent to the strength of the bone and the density of bone. But if our body is short on calcium, we don't have enough calcium in our diet, we can pull calcium from the bone to use in our body, because a lot of our body's processes utilize calcium. Muscle contraction uses calcium. So if we don't have enough calcium available in the bloodstream, your body will pull it from the bone and to use it. That obviously can be a bad thing if that occurs all the time. If you're calcium deficient all the time, your bones will start to get weaker because you're pulling so much of this mineral that gives bone its strength from the bone into the bloodstream. So calcium in bone, again, it's a reservoir for calcium. When blood levels are low, we basically can break down bony tissue using the cells called osteoclasts. We'll talk about them more. And release that into the bloodstream, increasing blood calcium levels. Bone also stores magnesium, potassium, sodium, and carbonate ions, which are going to be important for a number of, different functions in the body. But again, it's a storage site for these substances. Bone also, to some extent, sort of acts as a filter for the blood, and bone will store some harmful elements that can be found in the bloodstream, such as lead, radium, and strontium. So again, individuals that are exposed to these chemicals, they often will see an increase in these metallic elements in their bone tissue, and it takes a while to clear them from the body once they're stored in the bone. This picture, I'm not concerned that you know it, but I just wanted to kind of, it gives a kind of a good idea or an example of how calcium is stored. And it shows how calcium is going to be stored in the bone, but then also has the ability to be released by the bone into the bloodstream if necessary. A lot of, when you take physiology of exercise has a lot to do with maintaining homeostasis. Homeostasis is basically a term that means, a kind of a steady state or things being in balance. Calcium levels in the bloodstream are one of these things that your body tries to maintain in homeostasis, meaning it tries to keep it at a set level. So on this picture, what we can see is a normal blood calcium level is about 10 milligrams per deciliter of blood. And if we go too high, then your body will basically pull calcium from the bloodstream and store it in bone. If the calcium levels go too low, then we will release hormones from the parathyroid gland, which will cause calcium to be released from the bone and then into the bloodstream so it can be used. So again, our body's always trying to maintain this balance of calcium. If you have an adequate calcium diet, then in your diet, then for the most part, your calcium will stay in the blood or in the bone and maintain a kind of a fixed level. If you have excessive calcium in your diet, you will basically urinate it out. So, but if you don't have enough calcium in your diet, then we will see calcium pulled from the bone, and that can over time lead to the bone becoming weaker and developing osteoporosis. So now that we have an idea of the different functions of bone as it pertains to human movement, let's take a quick review of the organization of the skeleton and the structure of the skeleton. Obviously, these are terms probably you've used before, but the skeleton is basically broken into two main parts: the axial skeleton, which includes the skull, the vertebral column, and the ribs. So all of that central part. It does include the sacrum, but not the pelvic bones. The appendicular skeleton is basically the extremities. That includes the clavicle and the scapula on down through the upper extremity, and then includes the two pelvic bones and then the lower extremity. So we have the axial skeleton and the appendicular skeleton. Bones, again, in a review of the structure of bone, bone is, again, a unique tissue compared to most other tissues in the human body. It's a type of connective tissue, but it also is the kind of the densest and hardest tissue in the body, with possibly the exception of the teeth. But basically, the bone is a live tissue that is going to constantly be remodeling like others. So it does have a fairly significant capacity to heal, and also has a fairly significant capacity to change over time in response to the stresses we place upon it. However, it does change fairly slowly because of its very dense nature. So I wanted to go over a little bit about how bone is structured, and then how it can change this structure in response to exercise and stress that we place upon it. Because that's often what our goal is to increase the strength of bone when we're prescribing exercises for our patients and clients. So the outer covering of the bone is a tissue called the periosteum. The periosteum, peri means around, and again, this is the outer covering. The periosteum is kind of interesting. It has a very good blood supply, and basically the blood supply for the bone, which again, bone has a very good blood supply, it enters through the periosteum. There also are a very large number of nerve endings found in the periosteum, and free nerve endings primarily are responsible for the sense of pain. That's why fractures are so painful, why stress fractures are so painful, or you get up in the middle of the night and you bang your shin on the coffee table. That's why that hurts so much, because you've irritated the periosteum and, more importantly, the free nerve endings in the periosteum. So bone has very good sensory capability when it comes to sensing pain. The inner layer of bone is covered by a connective tissue called the endosteum. So basically, we're going to see that the bone grows from the outside in and is constantly remodeling, and again, moving from the periosteum towards the endosteum. Well, that's it for part 1 of this series. In the next presentation, we'll continue our look at bone tissue, specifically looking at bone cells, and how these cells are responsible for both bone remodeling and bone growth. We'll also take a look at the different bone shapes and how we classify bones based upon their shape. And then we'll look at a typical bone, in this case a long bone, and discuss kind of the anatomy of a long bone and why it's structured in the way it is. What we're going to see is bone is structured to be as strong as needed, but also light so that we can move more efficiently.